Okay, so in this question we are asked to figure out which one of these combinations can be used to make a buffer. Okay, so there's a couple things that we need to lay out first in order to answer the question. First of all, we're going to make an assumption, and we're going to assume we're going to be mixing equal volumes. Assume mixing equal volumes. Okay, so it's kind of a flaw in the question. I think they should have stated that explicitly, but we need to make that assumption in order to answer the question in the best way that we can. And in order to set the stage, I also want to remind you, how do you make a buffer? And we learned two ways to make a buffer. So first of all, remember that from a buffer, we can just make a mixture of a weak acid, okay, plus a salt with the conjugate base of that weak acid. Okay, so that's one way. Now the other way we can do it, or what we can start with is a weak base plus the salt with its conjugate acid. Okay, so that's one way to make a buffer. But the other way that we learned when we talked about titrations is that we can titrate a weak acid to the halfway point. Oops, I spelled that wrong. Halfway point. Okay, with a strong base. Because the idea here is that you're trying to get that mixture of a weak acid and its conjugate base, or what we can do is we can titrate a weak base to the halfway point with a strong acid. Okay? In that case, we would titrate a weak base to get a mixture of the weak base and its conjugate acid. So either way you do this, what you end up with is a mixture of a weak acid and its conjugate base, or a weak base and its conjugate acid. You can just start from scratch and mix together a weak acid with a salt that contains its conjugate base, or you could just start with a weak acid and then titrate it with some strong base until you get to the halfway point, halfway to the equivalence point. And that way you end up also with a mixture of a weak acid and its conjugate base. Okay, so now we can kind of look at all these options and see which one of them gets us to that kind of a mixture. All right, so one important thing to notice here is that if I'm going to kind of talk about option A down here. So if we add ammonia with some strong acid, right, that's what we're doing right here. Okay, we're titrating this weak base, but we're not going to end up titrating it to the halfway point. Okay, we're going to titrate it all the way to the equivalence point. Okay, and if we do that, what we've done is we've converted all of that ammonia into ammonium chloride. So where we did have the weak base, now all we have is the conjugate acid of that weak base. Okay, so that's not really going to make a buffer because we need a mixture of weak base and its conjugate acid, and this just completely converts the weak base into its conjugate acid. And again, that's because we have to assume that we're mixing equal volumes. Okay? All right, so what about B here? So B, we have a weak base, ammonia, and we have a salt that contains its conjugate acid. Ammonium ion is the conjugate acid. So that's a possibility. So let's look at the other options, but that one's looking good. So C here, we have a weak base, check. But this other ingredient is not the conjugate acid of this weak base. It's a weak acid, but it's not the conjugate acid of this weak base. So we can eliminate that one as a possibility. And the final option here, once again, we have the conjugate acid, but we're not mixing it with its weak base, right? So we have to have that mixture of a weak base and its conjugate acid, or a weak acid and its conjugate base. So we can also eliminate that one. So, as we thought, B looks like the correct answer.